For much of the last decade, artificial intelligence in consumer devices lived in the experimental phase. AI features were introduced as demos, previews, or optional tools designed to showcase what might be possible in the future. They were impressive in presentations but inconsistent in daily use. Today, that phase is quietly ending. Across smartphones, laptops, wearables, and home devices, AI is no longer treated as an experiment. It is becoming a utility. This shift is changing how consumer devices are designed, marketed, and used. In the experimental phase, AI was often isolated. Features were bolted onto devices rather than integrated into their core behavior. Voice assistants, image recognition, and smart recommendations worked in controlled scenarios but struggled in real-world conditions. Reliability issues, latency, and unclear value limited adoption. Consumers tried these features, then ignored them. US tech companies took note. The move toward everyday AI utilities began when companies shifted focus from what AI could do to what users actually needed. Instead of building one-off features, engineers started embedding AI into system-level functions. Battery management, performance optimization, noise reduction, and security monitoring are now driven by AI. These are not flashy features, but they are used constantly. This is what defines a utility, something that works in the background and delivers consistent value. One of the biggest drivers of this shift is reliability. Experimental AI tolerated occasional failure. Everyday utilities cannot. A battery optimization system that works sometimes is not acceptable. US tech companies have invested heavily in making AI models smaller, faster, and more predictable. This allows them to run continuously without disrupting the user experience. As reliability improved, AI earned a permanent role inside devices. Hardware evolution has also enabled this transition. Dedicated AI processors are now standard in consumer devices. These neural engines and accelerators allow AI tasks to run efficiently without draining batteries or overheating systems. When AI required excessive resources, it remained experimental. Once it became efficient, it became practical. Hardware and software co-evolved to make AI dependable enough for everyday use. Another key factor is the shift toward on-device processing. Early AI experiments relied heavily on the cloud. This introduced delays, privacy concerns, and dependency on connectivity. Everyday AI utilities increasingly run locally. On-device AI is faster, more private, and more reliable. This makes it suitable for constant background tasks that users depend on, such as voice input, image enhancement, and system optimization. Cost considerations also pushed AI toward utility status. Cloud-based AI is expensive to operate at scale. As AI features moved from novelty to frequent use, cloud costs became unsustainable. By processing more AI tasks on devices, companies reduced operating expenses. This economic reality reinforced the move toward efficient, embedded AI utilities. Consumer behavior has played a role as well. Users do not want to manage AI features actively. They want devices that work better automatically. Everyday AI utilities remove friction. They adapt to habits, anticipate needs, and improve performance without requiring attention. This aligns with how people actually use technology, not how they are shown to use it in demos. The maturation of software ecosystems accelerated this shift. Operating systems now assume the presence of AI hardware and services. Core features like search, accessibility tools, file organization, and security rely on machine learning. AI is no longer optional software. It is part of the operating system's foundation. Devices without sufficient AI capability struggle to keep up with updates. Another important change is how success is measured. Experimental AI was judged by novelty. Everyday AI utilities are judged by stability and impact over time. Does the device feel smoother after months of use? Does battery life improve? Are alerts more relevant? These outcomes matter more than one-time demonstrations. Privacy expectations also shape the transition. Users are more comfortable with AI that operates quietly and locally. Everyday utilities process data in ways that feel bounded and predictable. This reduces anxiety and builds trust. Experimental AI often felt invasive or unpredictable, which limited acceptance. Competition among US tech brands has turned AI utilities into a baseline expectation. Once one company successfully integrates AI into core functions, others must follow. AI stops being a differentiator and becomes infrastructure. The competition shifts from adding AI to executing it better. Importantly, this shift does not mean innovation has slowed. It has simply moved deeper into the system. Engineers now focus on efficiency, model optimization, and long-term behavior rather than headline features. This kind of innovation is less visible but more impactful. Everyday AI utilities also benefit from continuous improvement. Models can be refined through updates, improving accuracy and performance over time. Because these utilities are used constantly, even small improvements have noticeable effects. This feedback loop strengthens the value of AI as infrastructure. Looking ahead, the line between AI and standard software will continue to blur. Consumers will stop thinking of certain features as AI-powered at all. They will simply expect devices to be smart, responsive, and efficient. That expectation marks the true arrival of AI as a utility. The shift from AI experiments to everyday AI utilities reflects a broader maturation of consumer technology.